Alright, hey y'all, Mr. Kyle, Myers Mathematics, and let's just jump into it. I missed two of the series thingies that I was supposed to write. It's like a thing, but it's not a big deal. But I wrote them there just for my own sake, I guess. So if you're wondering why there's... Anyways, so determine whether the sequence defined as follows has a limit. If it does, find the limit. Limit sounds like lemon. So if we are looking at the first one, this would be about 1.4. This one is the same thing as the square root of 2 times the square root of the square root of 2, which, by the way, is the same thing as the fourth root of 2. Now, I don't know what the fourth root of 2 is, but the square root of 2 is about 1.4. I do have that one memorized. Okay, and then a sub 3. Well, we can actually split this one up as well, because that's the square root of 2. That is the fourth root of 2. And then this is the root of the root of the root. So it's essentially 2 to the 1/2 to the 1/2 to the 1/2, which is 2 to the 1/8 power. It's the root of the root of the root of 2. Right, so the reason why that's... oh, and then let's rewrite this. That's 1.4. I don't know what the fourth root of 2 is. I can probably type it into Desmos and find out in a second here. But the reason why this turns in, why that turned into a fourth, and this is going to turn into an eighth, is because this is the same thing as saying 2 to the 1/2 to the 1/2 to the 1/2, which then would be power times the power. You multiply the power, so it'd be multiplying those 1/2s, and then it would be 2 to the 1/8 power, which is the 8th root of 2. Right? So 1.4 times the 4th root of 2, and asterisks on these 1.4s because that's just a 1 decimal approximation. That's not actually what the square root of 2 is, right? It's irrational, so you cannot write it as a rational number, and terminating decimals are rational numbers. Which actually, I was reading the other day that a terminating decimal is also a repeating decimal. Fun little fact, a little side tangent. Bear with me here. 1.4 is a repeating decimal because this is the same thing as 1.40 repeating. I was like, what the heck? So you don't have to say that a rational number is a terminating or a repeating decimal. You can just say it's a repeating decimal. Because if it terminates, then it repeats at 0. Anyways, fun little thing I found out the other day. So it keeps repeating with that pattern. That's the pattern, right? Is that it's going to keep doing that. So if we stack these, if we stack them, then we snack them, then we would have the first term is just 2 to the 1/2. Then the second term is 2 to the 1/2 times. It's almost like you could write a recursive for this fairly easily. Oh, not yet. And then the third one would be this, and this, and this. So it's going to keep timesing by a smaller and smaller root of 2 as we go out to infinity. So actually, let's go ahead and look at what some of these numbers actually are. We know that the square root of 2 is about 1.4, but let's see what the other things are. So let's do this. F of x, I'm typing this into Desmos so you can't see it. F of x is, we'll just say 2 to the power of negative x. And then that way I can just type in the numbers. So if I want to know what... No, not 2. It's 2 to the negative x, so it's 1 over 2. No, hold on. Not negative. 1 over x. 2 to the 1 over x. There we go. That's what I want. 2 to the 1 over x. There we go. So that way f of 2 is, 1.4-ish, right? Okay, so we know that it's 1.4-ish. What about to the fourth? So 2 to the 1/4. 1.2. So actually, let's go ahead and get the other one to do decimal places. That's 1.41. So let's get rid of this. 1.41. So this is 1.41. This is 1.41 times, and then the next thing would be a 4. So 2 to the 1/4 power would be 1.19. 1.19. And then what is 2 to the 1/8 power? It would be 1.09. 1.09. 1.41 times 1.19 times 1.09. So it is getting a lot closer to, and then the next one would be the 16th, right? We're going pretty quickly here. It would be the 2 to the 1 over 16th power. 1.04, okay, and then 32 would be next. 1.02, then we'd have 64 next. 1.01, so you can tell that it's eventually getting to timesing by 1. Okay, well, if it's eventually getting to timesing by 1, then it'll start leveling out eventually. So, like, if I want to figure out, so it's that and so on and so on. So if we're going to infinity, then it's like an infinite recursive kind of thing there, basically. So I'm looking at this for the first time with you guys. These recursive ones, I don't always see how to turn it into an explicit right away. Now, it definitely does look like it's going to have a limit. So we can say that it will have a limit, and the reason why is because it's getting closer and closer to timesing by 1 at the end. So we're timesing something by something that's a little smaller, something a little smaller, something a little smaller, until it looks like it's leveling out at 1. And then if we're going to times by a bunch of numbers that are, as we go to infinity, are basically 1s, then it would stop changing as we go to infinity. So it will have a limit. As to what the limit actually is, though, that's an interesting question. We want to try to write it as an explicit. So we want to try to figure out a way to write these explicitly. This would be 2 to the 1/2 power. 1/2 plus 1/4 is going to be 2/4 plus 1/4 is 3/4. 3/4. Then this would be 4/8 plus 2/8, so 6/8, and then 7/8. So it looks like that might help us to write our series recursively, or explicitly, actually would be better. So we have, let's just say, so recursively, this is actually not that bad. Recursively, I could just say that it's a sub 3 times 2 to the 1/16. So that's how you could write it recursively. And then that would be, right, 8/16 plus 4/16. So we're at 12, and then 13, 14, and then plus 1 is 15. So 2 to the 15/16. So yeah, that's definitely the pattern, right? Is that the bottom is like a power of 2. So if we write this out, it would be a sub n is, the bottom is a power of 2. So let's start with the bottom. The bottom would be 2 to the power of, let's just throw an n there, but I don't think it's going to be n, because the very first term is a 2, the next term is a 4, and the next term is an 8. So it's actually, the power is not only, it's not doubling, though. It'd be nice if it was doubling, then I could just say, like, oh man, I've ran into something like this before, where you have to come up with like this crazy power thing. So it would be, wouldn't be 2 because I want it to double. 2 to the n would be like 2 to the n squared almost, but it's a power. 2 to the power of 2 to the n, maybe? Like 2 to the 2n? 2 to the, let's see, 2 to the 2 to the n. But we want to start at 2. So if n is 1, then that would be 2. If n is 2, then that would be 4. Yeah, I think that would work actually. 2 to the 2 to the n, not a parentheses as in like 2 to the 2 squared to the n, which would just be 4 to the n. Like 2 to the power of 2 to the power of n. That looks like that'll work because then when n is 1, I have just 2 squared. Oh, but 2 squared would be 4. Dang it. Then n is 2, and then I'd have 2 squared is 4, and then it'd be 2 to the 4th power is 16. So I went from 4 to 16. Oh man, I've ran into something like this before, where we're trying to get it to go 2, 4, 8, 16. What did I do? I was messing with this for a while. I remember I did something like this, and I was messing around with it for quite a bit. What did I do? Yeah, I ended up getting the answer eventually, but I was like cooking for like a solid hour the first time I saw one like this. It's gonna be a power of 2, and then it's 1 less than that. So it's essentially gonna go to 2 to the 1st power. Right? Because I mean, it's hard to write this explicitly, but just so we get to the answer, and you can let me know in the comments below if you want to see the work for this, because I've done this before, but it's really crazy trying to write this explicitly. Um, Essentially, it's gonna keep going so that the fraction gets closer and closer to 1, and if the fraction is getting closer and closer to 1, like the next one would be 31/32s. The next one after that would be 63/64ths, and so on and so on. It's essentially going to go to the power of 2 to the 1st power, which is just 2. It's getting infinitely close to that. So it should actually go to 2 for the answer here. So the answer is actually just going to be 2. So the limit as a sub no, the limit as n goes to infinity of a sub n is going to equal 2. So that's our final answer there. But as far as how to write it explicitly, just let me know if you want to see the work for that. I think I might actually I have the video because I did a video on it, and I think I stopped the video and like got rid of it, and then I like did some extra cooking, and then came back and like redid the video, and I was like, all right, so this is what I got. So I didn't have an hour-long video, but it is pretty crazy writing this explicitly. So yeah, just let me know if you want to see something like that. But otherwise, check out the 5 math mistakes everyone makes and how to avoid them. It's on my website, Myers Mathematics, which is the link is in the description below, myersmathematics.com. And I'll catch you all in the next video. Blessings, y'all.